Leave your stuff, go!
Ma'am, you have to evacuate.
Catastrophic fire. Sheriff's deputies went door to door.
Wildfire started
As smoke took over a popular shopping.
July 26, 2018. Redding, California. Tens of thousands of people were evacuating the west side of the city. They'd been told to go, so they packed what they could, medications, documents, pets, whatever fit, and they drove. And then people started pulling over. Not because the road was blocked, because of what was happening in the sky. A column of fire had risen out of the hills west of the city. Witnesses described it as looking like the atmosphere itself had torn open. Firefighters on the ground, veterans who had worked decades of wildfire seasons, were radioing it in and struggling to find words for what they were seeing. This is what was left behind. Not burn damage, impact damage, as if something had reached down from the sky and just swept through at full force. Scientists would later analyze the radar data, the satellite imagery, the wind measurements, and confirm what many people already suspected from the footage alone. What hit Redding that evening had never been recorded before in the United States. California had produced a fire tornado. To understand what happened that July evening, we need to go back 3 days earlier, to 1:15 p.m. on July 23rd. It started, almost laughably, with a flat tire. A pickup truck hauling a dual-axle travel trailer was rolling down Highway 299 near a place called Carr Powerhouse Road, right along the banks of Whiskeytown Lake in Shasta County, about 160 miles north of Sacramento. One of the trailer's tires blew out. The steel rim scraped against the hot pavement, throwing sparks. Dry brush along the roadside caught fire. At first, it was manageable, a small brush fire. Firefighters responded. No one panicked. But here's the thing about Northern California in late July. It is an absolute tinderbox. The region sees rain on fewer than 100 days a year, and 2018 was one of the hottest summers on record. The hills surrounding Redding were bone dry. The humidity was almost non-existent. For 2 days, the Carr fire grew steadily. Then, on the night of July 25th into July 26th, it exploded. Overnight, the fire jumped from roughly 4,000 acres to over 20,000 acres. It crossed the Sacramento River, a natural barrier that firefighters had hoped would stop it. The fire was now racing toward Redding, a city of 100,000 people. And that's when things got truly, historically terrifying. Before we get to that catastrophic evening, let's talk about what a fire tornado actually is, because there's a big difference between a regular fire whirl and what happened in Redding. You've probably seen videos of fire whirls before. Small spinning columns of flame, usually just a few feet tall. They happen whenever hot air rises unevenly and picks up a spin. Scary? Sure, but survivable. A true fire tornado, or pyrotornado, is a completely different beast. Here's how scientists believe the Carr firenado was born. Step 1. Extreme heat from the fire creates a massive, rapidly rising column of hot gases, called a pyrocumulonimbus cloud, or pyro-CB. Think of it like a thunderstorm, but powered by fire instead of rain. Step 2. That cloud shoots upward with incredible speed. In the case of the Carr fire, it grew from about 4 miles high to 8 miles high in just 15 minutes. That is almost impossibly fast. Step 3. As the column shoots upward, it sucks air in from all directions at the surface, like a massive vacuum cleaner. Combined with wind shear already in the region, meaning winds blowing in different directions at different heights, this air begins to rotate. Step 4. That rotation gets stretched and concentrated near the ground. The vortex descends, and what you get is a self-sustaining funnel of fire, wind, and ash with speeds exceeding 143 miles per hour, officially equivalent to an EF3 tornado. And here's the really unnerving part. The temperatures inside this vortex reached an estimated 2,700 degrees Fahrenheit. For context, iron melts at 2,800 degrees. The firenado was nearly hot enough to melt metal. Atmospheric scientist Neil LaRoe from the University of Nevada, Reno, who studied the event extensively, said the development of the pyrocumulonimbus cloud was the critical trigger. It stretched the underlying column of air, concentrating the rotation near the surface until tornado-strength winds were reached. He described it as a case of pyrotornadogenesis, a type of tornado formation that, before Redding, had barely even been theorized. This was, in the most literal sense, something new under the sun. By 7:30 p.m. on July 26th, the fire tornado was on the ground. Firefighters and residents reported seeing what appeared to be a glowing, rotating column of fire stretching miles into the sky, visible from across the city. Those caught near it described the noise as a constant, deafening roar, like a jet engine that never stops. One CAL FIRE truck driver reported that as the vortex passed near his location, every single windshield in his vehicle shattered simultaneously, not from fire, but from the shock wave of wind and debris being hurled at over 143 miles per hour. Bulldozer operators caught on Buenaventura Boulevard watched as the tornado lifted their massive machines and tossed them aside. Trees, enormous California pines, were debarked by the wind, not burned, stripped bare. That's how violent the winds were. The firenado remained on the ground for approximately 30 minutes, from about 7:30 to 8 p.m., before finally dissipating. In those 30 minutes, it killed at least 4 people. Jeremy Stoke, a 37-year-old fire inspector, was driving to help with evacuations when the vortex overtook him. He never made it out. And in a home in western Redding, a 70-year-old great-grandmother named Melody Bledsoe, along with her great-grandchildren, 4-year-old Emily and 5-year-old James, died when the firenado blew out the walls of their home and collapsed the roof. A neighbor had called to warn her to evacuate. She called her husband back to say she had the children and they were trying to leave. That was the last call. The firenado also toppled electrical transmission towers, knocked out power to tens of thousands of residents, and left entire neighborhoods that hadn't even been touched by fire looking like they'd been hit by a bomb. Roofs shredded, trees uprooted, signs torn away by pure wind force. The firenado may have lasted only 30 minutes, but the car fire itself burned for 38 more days. By the time it was fully contained on August 30th, 2018, the numbers were staggering. 229,651 acres burned, an area nearly 3 times the size of Washington, D.C. 1,604 structures destroyed, including over 1,000 homes. 8 lives lost in total. More than 38,000 people evacuated from their homes, and over $1.6 billion in total costs. At the time, it was the 6th most destructive wildfire in California history. And incredibly, it wasn't even the biggest fire of that year. That same summer, the Mendocino Complex fire burned over 450,000 acres. And just a few months later, in November, the Camp Fire would destroy the entire town of Paradise, the deadliest and most destructive wildfire in California's recorded history. 2018 was a catastrophic year for California. The car fire and the firenado it spawned became a symbol of how much worse these disasters were getting, and why. So the obvious question is, could this happen again? The uncomfortable answer from scientists is yes, and possibly more often. The conditions that created the car fire firenado weren't a fluke. They were a combination of factors that climate scientists say are becoming more common. Record heat. 2018 was one of California's hottest summers on record. As global temperatures rise, extreme heat events become longer, more intense, and more frequent. Extreme dryness. Low humidity and drought conditions turn vegetation into fuel. When there's almost no moisture in the ground or the air, fires burn hotter and spread faster. And a warming atmosphere. The hotter the atmosphere, the more powerful the updrafts a fire can generate, meaning the pyrocumulonimbus clouds that helped birth the firenado become more likely with every degree the planet warms. Atmospheric researcher Neil Leroux, who published his findings in the journal Geophysical Research Letters, argued that with modern radar and satellite data, it may actually be possible to issue advance warnings for fire tornado events, similar to how meteorologists warn for regular tornadoes. That's because the radar signatures of a developing pyrocumulonimbus are detectable before the vortex forms. The rotation shows up in Doppler data. If firefighters and emergency managers knew what to look for, lives could be saved. What happened in Reading wasn't just a disaster. It was a lesson. A painful, costly lesson about the new realities of fire in a warming world. The hills around Reading are growing back. Slowly. New homes have been built, streets repaved, trees replanted. The community that lost so much has in many ways rebuilt. But the Carr Fire and the fire tornado it spawned left a mark that goes far beyond the 229,000 acres it burned. It forced scientists to rethink what wildfires are capable of. It forced emergency managers to confront the terrifying possibility that fires can now generate their own weather violent enough to kill not just from flame, but from sheer wind force. It stands as only the second confirmed true fire tornado in recorded history, the first ever witnessed in the United States. A flat tire on a California highway triggered a chain of events that produced one of the most extraordinary and destructive weather phenomena ever documented. And in a world that keeps getting hotter and drier, the scientists studying this event aren't just looking backward at what happened in Reading. They're looking forward and wondering where the next one will form. If you found this video interesting, drop a comment below. What other extreme weather events should I cover next? And if you're new here, subscribe so you don't miss the next one. Thanks for watching.